So good morning, dear students.
Good
Hope,
morning, sir.
yeah, hope all of you
Good
are
morning,
doing
sir.
well. Good morning.
Morning,
Um,
sir.
Morning. So I think all of you are doing well, and your class test may start from 10th of October. Okay, so you have a few days left for your class test. So I think you are uh, actually preparing, okay, means these lectures. Okay, so just whatever lecture we cover, just parallelly you prepare the notes also. So to prepare the notes, I told you earlier also that you should follow some reference book, okay, and as well as NPTEL lectures and my lectures. So whatever content I will be covering in the class, so that content you just go through a book also, and you just see what are the things described in the book there. Okay, and if you face any problem, just you can ask me, okay, through phone call also, and through WhatsApp also, in my personal WhatsApp number also you can ask. Okay, uh, today is day
Sir,
3. Yes, Rehan.
sir, how class test one will be taken, sir? Means how, sir?
Yeah, class test one will be conducted. I think it will be through Google Class platform. So in Google Class, so I will be sharing the question paper. Okay, and the question paper, it will be of 40 marks. Okay, so earlier I told you that it will be 20, but no, actually it will be 40. Your class test total marks will be 40. Okay, so there will be total two class tests for this semester, so 40 and 40. Okay, so out of that 40% will be taken in your final assessment. So yeah, so you have to be prepared, and your syllabus will be definitely it will be module 1. Okay, and if we can cover 2 3 topics of module 2 also, then also we will include, means whatever it will be taught, okay, up to the last class before the class test 1. So that will be your this one. Rehan, please mute yourself. Okay, yeah. It will be good. Otherwise some, okay, disruption actually takes place. Okay, so today, as we have got two classes, so in the second class, that is at 3:35 or 3:40, so then we will be discussing one very important thing actually. Okay, so before that, actually I want to recapitulate what we have learned till date. Okay, so in our last class, so today we'll going to see what is the first law of thermodynamics. Okay, so to define that first law of thermodynamics, so we should have a very well grasp for this course. Okay, this thermodynamics. So from the very beginning, so actually this class will be a general discussion. Okay, better it will be a general discussion, then only I will be able to know that what extent you have come to know this subject actually. Okay, so maybe I can ask some things, okay, some of the things for the previous topics. Okay, just you need to just tell me when I ask. Okay, so actually see from the very beginning, if we will see, then at the very beginning, system and control volume. Okay, system, what is a system? I have told you that your refrigerator, your AC, okay, air conditioner, boiler, maybe you have heard about boiler, your flux. Okay, so anything which is taken under observation, so that is a system. Okay, but a system, to have a system, there should be some mass. Okay, there should be some mass, and there should be one boundary. That boundary may be one fixed boundary, or that boundary may be one imaginary boundary. Okay, so why I am calling it as imaginary boundary? Suppose your water pump, so what is happening inside the water pump? So water is coming through the inlet, and water is going from the outlet, isn't it? So through the inlet, so water is coming due to suction, okay, and at the outlet it will discharge, okay, up to a certain height, isn't it? But what we will actually consider, so when the water will be accumulating, so that mass of water is continuously changing, isn't it? But there will be a control volume inside the pump, so we can denote that control volume by some dotted line, okay, means within this region, so we will restrict our study, whatever amount of mass it will enter, whatever amount of mass it will go outside, but the total mass inside that imaginary dotted boundary will be remain constant, okay, just like that we will be assuming, okay. So that is why it is called, sometimes called as control volume, okay. So system may be a closed system or it may be a open system or control volume system. So that system is separated from the surroundings by a boundary. Okay, so the boundary may be a fixed boundary. The boundary may be an expandable boundary, because when we solve the problem of the balloon and cylinder when it was inflated, so the balloon was what? It was blowing, isn't it? It was inflated. So that is why the boundary was expanding. Okay, so sometimes the boundary may expand for some system. Okay, so that way also we will study or analyze any system. So anything, okay, means where there will be some mass, so that will be a system, but we have to analyze that system. Okay, means our observation should be done, so that will be a system. Okay, and I think that all of you have got the idea of what is a system. Okay, then surrounding and then your boundary. Okay, and system plus surrounding equals to the universe. Okay, then property, this is the syllabus actually. Okay, that is why I have taken this part, and I think it is visible to you also. So property, next one is the property. So property means what? So a system is having some means to define the state, to define the physical state of the system. So we need some parameters. Okay, so that will define the condition of any system. So property may be your temperature, pressure, volume, density, enthalpy, entropy. All these things are the property of a system. Okay, so by this property we will define the system. So the room where you are sitting, so the physical state of the room where you are sitting, so that can be defined by the temperature. The room temperature is 31 degrees centigrade or 25 degrees centigrade. Pressure is 1 atmospheric pressure. So by all these parameters, so you will define the system. Okay, so then only your system can be defined physically. Okay, then state, what is a state? So when this property will attain some fixed or some uniform value, so your room is having 27 degrees centigrade, so it is uniform throughout your room. Okay, so means it is not changing. Now it is 27 degrees centigrade, and after 2 minutes it will not 28 degrees centigrade. It may happen after 1 hour or half an hour, but at a particular time you are getting some uniform temperature, uniform pressure, okay, throughout the room. Okay, so that state where your properties are fixed for a particular time. Okay, so that state, that condition is called as a state, and that state should be equilibrium state. I have told you that state should be equilibrium state, means no interaction of energy and no interaction of mass can takes place at that time. Okay, otherwise if mass will enter, what will happen? Molecular interaction will be there. So molecular interaction means molecular collision. So molecular collision means increase in temperature, isn't it? So it should be in thermal equilibrium state. Okay, then when we have defined the state, so then we have come to know what is thermodynamic equilibrium. So to attain thermodynamic equilibrium, there should be three equilibrium coexist in a system. One is your thermal equilibrium, then chemical equilibrium, then mechanical equilibrium. So what is thermal equilibrium? So when the temperature, okay, will be remain constant, then it is called as thermal equilibrium, means no heat is going out, no heat is coming in. Okay, so temperature is that parameter which is measured due to the transfer of heat. Okay, or temperature is that parameter which is responsible for the conduction or the transfer of heat. Okay, so the temperature will be remain constant, thermal equilibrium will be maintained, and the generated. In endothermic reaction, some heat it is absorbed, isn't it? So if heat is absorbed, then total temperature it may change, isn't it? So the if heat is coming from the system, okay, means some exothermic reaction is happening, the temperature may change. Okay, so it should not happen to define a state. Okay, so it is a thermodynamic equilibrium state actually. So when you are defining any state, then your mechanical equilibrium. Mechanical equilibrium means the system should not do any work. Okay, because work and heat they are interchangeable. Okay, so work can be converted to heat. Means suppose one ball it is coming with a very metallic ball. Let's say metallic ball it is coming with a very large velocity, and if it is stopped, okay, with a restriction, so what will happen? So you can feel the heat on the surface of the ball, means the total amount of work it is converted to heat actually, isn't it? So that mechanical work should not happen within a system or on the system. Okay, then also there should be some imbalance of the properties. Okay, so that way we have defined the thermodynamic equilibrium. Then one process, so we have defined one process. So process is what? It is a actually suppose say your room temperature is 27 degrees centigrade. So after 1 hour, what will happen? Your room temperature, when the sun will be heated, so when the sun will throw heat, so after some time at noon, what will happen? Your temperature will be, it may raise to 32 degrees centigrade. So 5 degrees centigrade, from 27 to 32, it is changing, isn't it? It is changed. So why it is happening? Because of the interaction of heat from the surrounding to your room, means to the system. Okay, suppose your room is your system, so it will happen. So uh, so your system has done some process, that is why your temperature has raised from 27 degree to 32 degrees centigrade. But from 27 degree to 32 degrees centigrade, it is not happening within a fraction of time. Okay, so it is happening by attaining some thermal equilibrium point. Suppose 27 degree at 10 o'clock, at 10:15 it will be 28 degree, at 10:30 it will be 29 degree. So just like that, it will attain some thermodynamic equilibrium point. Okay, and finally at 12 o'clock or at 1 o'clock, what will happen? It will reach 32 degree centigrade. Okay, so when you will plot all these points, then what you will see, that all the points are in thermodynamic equilibrium point. So you are able to join all these points by a distinct line. Okay, so this means what? So from 27 degrees centigrade to 32 degrees 32 degrees centigrade, one process happens. That is why uh, you are able to join all those thermodynamic points. Okay, so this process is also called as quasi-static process, means numbers of thermal equilibrium points will be there on the process line. Okay, whatever line it will be there. So in PV diagram I have shown you the process how it will happen. Okay, so this concept of this thermodynamic equilibrium and temperature scale, actually this gives rise to a the definition of actually temperature, and as well as it gives one definition of zero law, that is called as zeroth law of temperature. Actually this zeroth law, what it is actually, this zeroth law actually comes after first law and second law. That is why you cannot say it is a third law of thermodynamics. That is why it is placed above first law of thermodynamics. That is why its name is zeroth law. Okay, so that is why this name is zeroth law of thermodynamics. So what does it mean actually, zeroth law of thermodynamics? So suppose there are two bodies A and B. Okay, so their properties are, let's say their properties are this one different properties, they are having different properties. Okay, so I have taken as XA, YA, XB, YB. Okay, because two parameters are needed to fix the property, okay, for a particular system. Okay, so I told you the Gibbs phase rule. So from that phase rule, so to the number of independent parameter which is required to define the state, so we have found out by the Gibbs phase rule. Okay, so XAYA is the property of this one system A, XBYB are the properties of, so here I think it is there, let's oh, it is not there. Okay, no problem. Yeah. So XBYB. So what will happen? So they are when they are separated by an what this one diathermal wall. Diathermic wall means what? So insulation. So there will not be any change of what properties, okay, or temperature one from one body, the heat will not flow to the other body like that, okay, because it is suppose adiabatic wall. Let's say it is adiabatic wall. Adiabatic wall means what? It will not permit the allow of energy, okay, in between the two systems. So in my video, so that thing actually I discussed, okay. So if you can recall that video, that one system was there on the left hand side, one system was there on the right hand side, okay. So the property was XA, the property or the B is XB, YB. Then the two bodies are actually joined by an adiabatic wall. Okay, adiabatic wall means no transfer of heat, it is taking place. Now what we will do? We will introduce another body. Okay, C, which property is XCYC, which are different from both A and B. Okay, means all the properties in three bodies are different. Now what we will do? A and C I will connect. Okay, so when we will connect A and C, so then it will happen that the properties of A and C will be equal, okay, and when we will connect B and C, the properties of B and C will be equal, okay. This means what? When two bodies A and C, when A and C are in thermal equilibrium and when B and C are thermal equilibrium, then we can say that system A and B are also in thermal equilibrium, okay. So in word, what you can say that when two systems are separately in thermal equilibrium with a third system, then both the systems means A and B are in thermal equilibrium. So that is the zeroth law of thermodynamics. Okay, I think you have understood the concept. Then temperature scale means how you will define this temperature. So basically in microscopic thermodynamics, the temperature is the molecular in this collision, okay, when one particle it is collide with another particle, the amount of energy which is associated with the particular molecule in microscopic thermodynamics, it is defined as temperature, okay, and in macroscopic the average rate of change of average kinetic energy, okay. So that is the temperature for a for macroscopic, okay, or classical thermodynamics. Then various thermometers, so I have tabulated various thermometers. So in details actually we don't need, but what are the constant for isothermal thermometer, the temperature will be constant. So like that the parameters which are fixed in various thermometers, so you should remember, because that things are basically asked in some competitive examination, okay. Then definition of heat. So heat is a property which flows due to the difference of temperature, okay. So examples of heat work interaction in system, okay, means I have told you when a moving ball, metallic ball, it is stopped, okay, suddenly when the velocity becomes zero, then what is happening? The total heat is converted, total work of the ball is converted, because it is having some kinetic energy, so it will be doing some work, okay. So it is displaced, some force is acting and it is displaced, so there will be some work energy, so it will be converted to heat, okay. And that the heat which is associated with the ball can be calculated, can be measured when you are insulating the ball, okay, from the outside. So then your total heat can be measured by some thermometer or thermocouple, okay. Then this one, first law of thermodynamics, so we will study in our next class, okay, which is at the last period. So this we will cover. So before that, so one small topic actually it is left, which is important. So before this heat and work interaction, yes, so we have defined the PdV work, isn't it? So PdV work is the displacement work, isn't it? So the displacement work, I will show you. So how it was measured actually. Yeah, so again this one actually sign convention, it is this, I think you have remembered this drawing. And when work is done on the system, so we will take heat as work as negative when work is done by the system, okay. This is the system, so it is doing some work on the surroundings, so these all things are the surroundings, okay. So it is doing some work on the surroundings, so it is positive. So when Q is entered to the system, it is positive. When Q is coming out from the system, it is negative, just like endothermic and exothermic reaction. Okay, so then our expansion or compression displacement work. So we have defined the displacement work. Okay, so it is PdV. So PdV is the work. Why it is PdV? I have told you, because gradually the system will move, the boundary will move. Okay, means boundary will move means what? There will be a difference in volume. Okay, means as there is a difference in volume, so we are writing dV. Okay, so pressure into P into dV. Okay, so from state 1 to state 2, that is why. So total work will be integration 1 to 2 E dV will give you the total work for one process. So for 1 to 2 this process, so the area under this curve will be the work done. So this will be calculated by integrating PdV from point 1 to 2. Okay, so here you can see from this uh, drawing that there is a change in volume. At 2 the volume is more, at 1 the volume is less. So from here you can measure this volume. Okay, so after this PdV, yeah, so I have given some videos actually. So I think all of you have gone through those videos, so where you are able to find out what is a point function and what is a path function. Okay, so point function means what? So this is one process from 1 to 2, this is one process. Okay, from 1 to 2, from for this path B, this is another process, and from 1 to 2 this path is C. Okay, so means A, B, C are three paths by which you are reaching from 1 to 2. Okay, so if you are asked to find out what is the temperature, okay, or what is the temperature in between point 1 and 2, so directly what you can do, from 1, suppose this is temperature scale, here property 2 is, let's say, temperature. So what you can do from point 1, so if you project this point here on this axis, so you will get this point here, and from 2 if you project here, this one will be your projection point. Okay, so by this difference you can find out the temperature, or by this difference you can find out the pressure if this is pressure axis. So means by the difference of this point, so if you can find out any parameter, so that parameter is point function. Okay, means point to point it will depend. Okay, it will not depend by this part. Okay, so means from this point to this point, so if you calculate, if you want to calculate what is the temperature in between point 1 and 2, so directly P1 minus T2 you will get the temperature. So what is the pressure? P1 minus P2 you will get the pressure. Suppose this is volume, so V2 minus V1 you will get the volume. Okay, means the amount of expansion in the system or the contraction in the system. But to find out the what is the amount of heat in the process A, what is the amount of heat in the process B, what is the amount of heat in the process C, or what is the amount of work in process A, what is the amount of work in process B, and what is the amount of work in process C are different. Okay, though the initial point and the final points are same. That is why this work and heat are the path functions, means it will depend on the path by which it will uh, do the process. Means from here to here, if this is the path, so the heat will be different, the work will be different. Okay, but the temperature, pressure, volume, all these are the point functions, means directly by subtracting the final point to the initial point, so you will be able to find out the pressure, temperature, volume, enthalpy, all these things. Okay, or not enthalpy, so all these things. So these all parameters are point function, but work and heat are the path functions. Okay, so you should remember this point. Okay, these are the path function or state function. Okay, sometimes it is also called as path or state function. Okay, so point functions are the functions or properties of the system, temperature, pressure, volume, so which can be find out by directly subtracting the final point to the initial point value. But path functions are the functions which depends entirely on the path. So from this to this, for this path A, the values will be different for energy, this work, and this one heat. And for path B, though the initial point and the final points are same, but it will depend on the path B. Okay, means it will be having a different value. Suppose it will be 2 joule, it will be 2.3 joule, it will be 2.4 joule, it may happen. Okay, so we will find out all those things when we will be doing some problem. Okay, so it is very much important. So one very important thing actually, yeah, better I will, yeah, I think this slide is visible to you all. Yes or no? Please, anyone respond?
Yes, sir.
Okay, so I will
Yes, sir.
take one good quality photograph, then I will share with you. Okay, so see the process. Okay, same process. So let's say that same process. Okay, this type of process. So it is also one process, state from state 1 to state 2 after expansion. So you are getting the state 2. So when you are joining in PV diagram, this is P, pressure and volume diagram. So you are getting this process. Okay, so you can say this type of process you are getting. Okay, so in another process, so how this PDB work can happen actually. So here you can see PDB work in various quasi-static process. So when you are just using this or quasi-static process, so there are certain fixed processes in thermodynamic cycles, okay, in thermodynamic systems or in thermodynamic process. I have told you there are cyclic process, reversible process, all these are the basic process, but here these are the quasi-static process. Okay, PDB work in various quasi-static process. So what are quasi-static process? So first one is your constant pressure process. Okay, so any process can happen in constant pressure. When the pressure is constant, suppose your where the room where you are sitting, so that will be your system. So in that room, suppose your pressure is constant, but you are increasing the temperature. Okay, so it may happen. Suppose your volume is constant, you can increase the pressure also sometimes, isn't it? Because your room will not expand when you will increase the pressure, when you will increase the temperature. So total volume will be fixed. So your process will, in some of the thermodynamic system, some processes will happen in this way, that total volume will be constant. Okay, so in compressor the total volume will be constant, but you can increase the pressure inside a compressor, isn't it? So some boiler in the pressure will be constant, but temperature will be different. So just like that, some of the components are there in thermodynamic system or in our day-to-day life or in machineries, so where these type of conditions will be there. So you should know for different processes what will be different work. Okay, for different processes what will be different PDB work. So it is a constant process, constant pressure process. Let's say it is a constant pressure process, and how this constant pressure process will be denoted. See here, this is constant pressure process, because from state 1 to state 2, so this will be one process. So here pressure is constant. If you project it here on the pressure line in this axis, so this is pressure is constant from state 1 to state 2, but volume is increased from V1 to V2. Okay, so you cannot make both these two things constant, but yeah, you can control one parameter easily. So pressure is constant, volume is increasing. Okay, so when your piston cylinder arrangement you have taken, so you can control the pressure. Let's say pressure is constant but volume is increasing. Okay, so you can easily suck this one piston. Okay, you can by some doing some this one by making this control environment, so you can make the pressure constant inside the cylinder. So for this type of case, so your drawing will be this one. Okay, and this will give you your PDB work. Okay, or the displacement work, because area under PDB curve will give you this displacement work. So how you will find out the total work? So W1 to 2, because from 1 to 2 for this process, okay, where pressure is constant, constant pressure process is called as isobaric process. Bar is the unit of pressure, isobaric process. So for this here it is written as isopestic process or isobaric process. Okay, so isopestic or isobaric. So for this process, how you will be finding out the work done? So PdV. So from volume 1 V1 to V2, because volume is changing. Okay, so PdV. So pressure is constant, so P will comes out. So dV, for dV, integration of dV is V, upper limit minus lower limit. So V2 minus V1. So P V2 minus V1 will be the work done. So if you are asked to find out, so what is the this one work done for this constant pressure process, so you will have to use this formula, and this is the drawing. And for constant volume process, so in some system, so your volume will be constant, so you can increase the pressure. So for that, what will happen? The total work done will be 0, means there will not be any work done, because the boundary of the system will not move, and if there is no displacement, there is no work. You also know by mechanics, isn't it? So as because there is no displacement, okay, so there will not be any work, so pressure is changing. Okay, but dv equals to 0, there is no change in volume, so it will be 0. So this is the control volume process. So from 1 to 2, the this line will say that the volume is constant, the pressure is increased, okay, or pressure is decreased, okay. From here P1 to P2 pressure is decreased, but total work done will be 0 for this process, for 1 to 2. So you cannot draw this one. So now you have to draw, for an isochoric process you have to draw this line from 1 to 2, because this volume line, this line will say that the total volume is constant, there is no change in volume, no initial volume, no final volume, okay. Means there will be that volume, but v1 will be equals to, or v initial equals to v final. That is why this term dv will be equals to 0 and total work done will be equals to 0, okay. And physically you can say that for this piston cylinder arrangement, if you want to increase the pressure without changing the volume, so this piston will not move anywhere on the left hand side or right hand side, it will not move, so the displacement is 0. That is why the work done is 0, okay. So in mechanics also, if displacement is 0, the work done is 0, okay. So up to this much, so I am just uh, stopping here, okay. So in the next lecture, so we will see, okay, process for other work done for other processes, and we will today define the first law of thermodynamics, okay. So thank you, dear students. So now you can leave this meeting, because you are already 5 minutes late for the second class. Okay, thank you, students.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.